Hi folks, welcome back. In this video, I will be explaining about the classic load balancer implementation using Terraform. So as you can see on the screen, this is the architecture which I'm about to implement. And in this architecture is based on the previous one where I have already implemented the VPC 3 tier and then three EC2 instances. One is a Bastion host EC2 instance and the other two belongs to the private subnets for each availability zone, and those two are private EC2 instances. So with this basic architecture, I will be implementing a classic load balancer initially. The purpose of the classic load balancer is to have a basic understanding of which we will be able to further discuss about the application load balancers and then the network load balancer. I know this is not used in the production scenarios, but just for the sake of understanding, I will be starting off with the classic load balancer, and in the next videos I will be explaining in depth, in detail about how to implement an application load balancer in the Terraform. But before that, we need to have a basic understanding of what load balancer is. Hence, I've taken a very simple example of a classic load balancer. And what this load balancer does is that it is going to receive the requests from its associated DNS, and it's going to load balance across both the private EC2 instances. So it's very simple. And in this scenario, what I have done is that I have taken two different ports, port 80 and port 81. Port 80 is the usual HTTP port, and port 81 is a custom port. So with both the ports, the load balancer DNS is going to receive the request, and it's going to load balance across both the private EC2 instances. So this is the basic architecture. And now let's go to the code. Before I go to the code, I would like to explain the Terraform module for the elastic load balancer, which is the classic load balancer. So as you can see over here, since it's not much used in the production scenarios, we have less number of downloads, which is 721, almost 722 kilo, but that's okay. And now we have the overall basic structure of the Terraform implementation of the classic load balancer. This is the basic code structure which I have taken it over here. Okay, and so right now, so this is the so this is the resource which I copied and pasted over here, and the module I have implemented from here, which is a core module that has to be implemented with the fixed version of 4.0.1. Then I have the naming convention, and then we have the subnets. I've taken the subnets because, as you can see in the infrastructure, the classic load balancer always sits on the public subnets. So for that reason, I have taken the public subnets with the module implementation. Since we have two public subnets, I have indexed it using 0 and 1. So this is subnets, and also the classic load balancer has its own security group, and this security group has two ports enabled, which is port 80 and port 81. So let me show you how that's implementation as well. So as you can see over here, so in this particular subnet, in this particular security group, I have implemented the ingress rules, which is the port it accepts port 80, and it can accept from anywhere. And when it comes to the custom port implementation, we are going to do something like this: ingress with CIDR blocks, and in the CIDR block, so this is going to be the first rule where it accepts port 81 with a protocol 6, and it can be some service name. We can give the description as we like, and it accepts from anywhere. So this is port 80 and port 81. So this security group is already created, and this security group is assigned to the load balancer, which is right over here. So that's the explanation. And then it is not going to be an internal load balancer, it's going to be an external load balancer, because we will be reaching those EC2 instances using our browser. Browser means it's going to be public. So it's going to be a public load balancer, and internal is going to be false. And as we have defined in the security group, we have defined port 80 and port 81. So the instance port is going to be 80, which will be constant, because the instance has the HTTP load balancer, the HTTP port, and the HTTP port is open only to port 80. So that's the reason instance port is going to be fixed with number 80, and the protocol is going to be HTTP, which is at the application layer 7, which is at the layer 7 protocol. And coming to the load balancer, what load balancer ports is going to be activated? So it's going to be port 80 and port 81. So as you can see in the architecture right over here, this particular load balancer DNS accepts only port 80 and port 81, and that's what I have defined over here. And then we have the health checks, the routine health checks, and then the tags, and then the number of instances. This particular load balancer is going to be assigned 2 private EC2 instances, and for this the number is going to be 2, and I have referenced both the private EC2 instances with their respective IDs. The reason I have implemented for loop is because I will be getting an error message, something like this. Let me show you. Okay, that's a long scroll. Bear with me. Trust me, I have implemented like twice or thrice to have this proper implementation, because before that I was getting a lot of bugs and errors, and that has to be fixed. And after like 4th or 5th implementation, that was successful, and that's why I have so many commit histories. I'm just waiting for that error message to come up. Yeah, there we go. And this is just one of them. Yes, and as you can see over here, it says the object does not have an attribute name ID. The reason I was getting that error message is because once I define the private instances something like this in terms of list, it is for some reason it's not getting accepted. So for that reason I have implemented a for loop, and it was successful. And once your code is ready, so it's going to be Terraform, the Terraform lifecycle, which is Terraform init, Terraform plan, Terraform init, validate, plan, apply. And once the apply is complete, then we have the load balancer, which is then we have the architecture implemented, and this architecture will have a load balancer, and this load balancer will have its dedicated DNS. Let me show you about that. So this is the load balancer which is got implemented, and this is the DNS. And as per the architecture, it is supposed to have both port 80 and port 81. Okay, so let's check with that, and this is going to be port 80, and there we go. So with port 80 it is working, and then let's go with port 81 as well. Done. So both the ports are working successfully, and yeah, so this architecture is implemented. And then we also need to check to which particular EC2 instance this is load balancing, right? With this thing, let's go with app1 metadata.html. So if we take the instance metadata, right now the private instance, let's check the private IP. It's going to be 10.1.51, and so private and bastion host according to the architecture which is already implemented. And let's check the private IP instance. Okay, the first one is 2.209, and the second one is 1.51. So right now the instance is landing at 1.51. If I refresh it, now it goes to 2.209, which goes to the first instance. So likewise, let me refresh again. Yeah, again it goes back to the second instance. So likewise, it keeps load balancing. Once it receives the request via port 80 or port 81, via its DNS. So it's going to be load balancing across both the private instances. Right. So this was the architecture, and this was its implementation. And this particular code is in the GitHub repository. Make sure you check it out. Try to clone it on your computer. Try to make changes. Try to implement it on your own, and you'll have a rough idea about how you'll get an idea about how this implementation is taking place. In the next couple of videos, I will be explaining about the application load balancer basics and the application path-based routing, and then the application queries. So these are going to be some of the important topics which I'll be discussing in the next video. See you there.